So today is the 4th of April, I believe, and we're looking at the pedigree worksheet. So we've got paternal grandparents with an affected grandmother. Dad's got 2 sisters, 1 affected. Maternal grandparents, grandfather is affected. Mom's 1 of 4, nobody affected. And of the 3 offspring, 2 are unaffected, 1 is affected. This is you. So if you're a boy, that should be a square. If you're a girl, that should be a circle. That's going to be different depending on who you are filling that out. Okay, now let's flip to the back. Given this pedigree, and we're asked some questions about it, and the very first question is the trait that we're showing here dominant or recessive? What is it?
Recessive.
You think it's recessive. Who else says recessive? Who says dominant? Who says you can't tell? Okay. It is recessive. Now, here's where the rubber meets the road. How can you tell that? It is recessive, and I can bet you $5 that you all come up with the most common wrong answer. What do you think, Callie?
One of the parents were affected, and at least 25% of their offspring.
Okay, so you have 1 in the grandparent generation, you mean. So you've got 1 grandparent affected, and it's a small percentage of offspring that are affected. Well, that would probably point towards it being a recessive, but it's not the proof. What's the proof? So what are some other reasons people have? And that's very numeric. I love numerical data. What do you think?
I wrote down, because I just wrote down there are less blacks on there that mean I'm affected.
Okay, there are fewer affected individuals than non-affected individuals. And that's pretty much what Callie's saying, that there's a very small percentage of individuals who are affected and a larger percentage who are not. But that's not it. What do you think?
It seems to skip the generation from the grandparent to the twins.
Well, there's somebody in that second generation who's affected. They have an uncle who's affected.
An uncle, but not directly given.
Yeah, but that's still not it. But you're getting closer. You're like right on the edge of the answer. What do you think? Well, that's what Nate just said, and the 2 of you are right on the edge of the right answer. What does it mean if it skips a generation?
Well, I was going to say you have 2 non-affected parents, and then you have an affected.
That's it. If you look at these guys, neither of their parents are affected. It skipped a generation, which is what you're saying, but what you need to say is those parents have to be what? They have to be carriers. You can't have an affected offspring with unaffected parents unless it's recessive. So this has to be a recessive trait because you have non-affected parents having affected offspring. And we call those people carriers, of course. Okay. So, on to Moser's mean, nasty trick questions. Would I do such a thing? Of course I would. Whoops. So which side of the family, which side of her family, did the affected female in generation 3 receive the identified trait from? Where did she get this trait? Where did she get it? Who says her mom's side? Who says her dad's side? Who has some other answer? So, if you say mom's side, justify your logic. Why do you say she got it from her mom's side? Explain yourself. So here's our affected female in generation 3. Where did she get this trait from? What do you think, Callie?
The grandmother on the maternal side.
So she just got it from her maternal grandma.
Because her grandma makes her mother a carrier.
What about her dad? This is a trick question, folks. It's a recessive condition. Guess where she got it? Both sides! What? If it is a recessive condition, you cannot be affected unless you got a recessive gene from each parent. So we know that Dad had to be a carrier. He had to be heterozygous. He's not affected. None of his siblings are affected. We might have 20 generations in his family where nobody was affected. But they're carrying that recessive gene. Maybe they've never partnered with another carrier before, but this time it happened. He's a carrier. Obviously, the mother's a carrier also. So if it's a recessive trait, which side did they get it from? Both sides. They have to get it from both sides. Okay. Oh, here we go. Number 4. Why could you say that the 2 affected males in the 3rd generation would either both be affected or neither be affected? Why?
Because they're twins.
What kind of twins?
Identical twins.
Identical
So
twins.
Share the same.
They share 100% of their DNA. All their chromosomes are the same. If they were fraternal twins, would that be true? No, because they'd be 2 eggs, 2 sperm. In this case, those guys started off as a single fertilized egg. And splitting went wrong someplace. Are your twin siblings identicals?
We don't know.
Oh, okay.
We
So
never found out when they were
close enough to maybe.
Some people think they are, but I was going there like
Okay.
I don't think they are.
So anyway, obviously same sex then. All right. So yeah, these guys would either both be affected or neither be affected because they've got all the same chromosomes. They have all the same DNA. Number 5, how can any offspring in that 3rd generation be affected when their parents aren't? Sage, stop. How can we have offspring, who are affected here, thank you, sir, when their parents are not affected? Talk about it at your table. Discuss. How is that possible? How is it possible that we have affected offspring with unaffected parents? Yes, sir. Okay, I'm hearing some people using the term, take it out, carriers. Their parents are carriers. So they can be affected even though their parents aren't affected because it's a recessive trait and their parents are carriers. Okay, can you predict the genotype of that affected female in the 3rd generation? Can you tell her genotype?
No.
Yeah, of course you can.
She's affected.
She's affected, which means what's her genotype? It's homozygous, dominant or recessive? Recessive. So, if you're using N, it would be little n, little n. If you're using E's, it would be little e, little e. We don't know what we're talking about here, but it's 2 little letters. We know that she is homozygous recessive. You could use PP. For some colors, for some characteristics in pea plants, we actually do use peas for blossom color because purple is dominant. Okay, so that's number 7. What do we think her genotype would be? And number 8, can you answer these questions without knowing what the trait is? So who says yes? Who says no? Who's too chicken to commit to a position? I like making chicken noises. That's really why I do that.
Yeah, you need to go on a farm.
Yeah. So you can answer these questions. You just did it.
Huh?
Whoa.
You can answer these questions without knowing what the trait is. Yeah, I just did. How can you know? How can you answer these questions? So yes, you can absolutely answer these without knowing what the trait is because patterns of inheritance for dominant traits are standard for any dominant trait. Patterns of inheritance for recessive traits are going to be standard for any recessive trait. Now, you're going to turn that in with your corrections. So, as I said, I don't want you to have erased your wrong answers. I just want you to write your correct answers near them. You're going to turn them in, and then we are going to start working on doing the pedigrees for your genetic counseling project. So you'll need to get out your genetic counseling project, go ahead and turn in the worksheet, and then get out the genetic counseling project. Okay, so for the genetic counseling project, we're going to do this sort of in chunks together. And today, what you're going to work on is creating the pedigree for each of your clients, for each couple who's coming to you. this is a little bit different. It's sometimes confusing because we're going from where we've typically been doing the pedigree sort of from the top down and saying, oh, well, they had 3 kids, and then, you know, this one had 3 kids. We're now starting from the bottom and working our way backwards. And this is the way pedigrees are more commonly done. If you did a pedigree for yourself or for your dog or your horse or whatever, you're working from the bottom and you're moving backwards to look at ancestry. So it does get a little bit confusing. If you look, and you should have your genetic counseling packet out, your clients are a husband and a wife. Okay? So you've got the wife, then you've got the husband. It tells you what condition they're concerned about. And it's going to give you as much family history as they've got. There are a couple cases where there's no family history. I know there's one where like the father is unknown, and that happens. Somebody may not know who the father was, or he may just never have been part of the picture. We have cases where grandparents are unknown. We have cases of people who died early, and so there isn't a whole lot of information about them. So there are cases like that when you're doing a family history. We're going to start off, and I'm going to start off actually with the PKU case. So if you have PKU, lucky for you, because I'm going to kind of do the pedigree partly for you. Now, that said, you can do this on a sheet of notebook paper because this is your rough draft pedigree. You are going to do this pedigree more than once. When you turn this in the final time, you are going to be using blank paper. Do you notice how I've evenly divided this? I actually measured it with a ruler. I drew lines. I marked my generations. It is going to be super neat, and it's going to be beautiful. Because what your final product for this is basically going to be a professional packet with pedigrees and Punnett squares and a letter to the clients telling them a little bit about the disease and telling them about basically their chances and what they need to know. And it's going to be sort of a final professional packet. You can do your rough draft on regular paper, but your final pedigrees will be beautiful. They're going to be gorgeous. And if you screw them up, you'll just do them again because they're going to be perfect. You know, hey. Because, oh, did I mention that this is going to be in lieu of your test for this unit? So this is going in as a test grade. This is an assessment of your knowledge of the genetics material that we're covering. Which means if you historically struggle with test anxiety or something else and your test grades have been lower, this is a chance to do something that we're going to work on in pieces, and you get this as your test grade. So you have every chance to get 100% on the test because we're going to be working at this pieces and pieces and pieces. So it's kind of helpful. Okay, so for my family here with PKU, I'm going to start off. Here's the wife. Here's the husband. I'm starting with them at the bottom of the page. And in some cases, especially when you're doing the rough draft, you just do hers and then do his, and then you figure out how to draw it all on one axis. I usually have my students put a star or something on the client so we know who it is that we're looking at. I actually went online last night and I looked at the International Association of Genetic Counselors, and they have a whole document that has all the standardized forms that they use for pedigrees. And some of the cases that were brought up yesterday, like sperm donation, adoption, they have all kinds of protocols for that stuff. They have protocols for people who have a baby using donated eggs, because that happens. If you are a woman who's not producing eggs, but you can have donated eggs from a stranger, or like if you have a family member who says, yes, I will give you an egg, you can have that egg fertilized and implanted, and you can carry that child. So they cover all of that. It's really pretty amazing. And they mention that as reproductive technology kind of gets more complex, so do pedigrees. And they say, there are some things that still aren't quite standardized. Here's what's commonly used. We're moving towards standards, which is great. It's good that they're thinking about that stuff. So what they typically do to denote the client, the person we're talking about, is they put a little arrow. You can do either one. I don't care. I think the arrow kind of gets in the way of other stuff around it. So I still like the star. And, we aren't actually professional genetic counselors just yet. Maybe some of you decide you want to be. I don't know. So I'm starting with the mother here, and she has no family history of PKU. She is the fourth of 6 children, so I need to draw 6 siblings for her. 1, 2, 3, 4, 5, 6. And what do we have? Now, it says she's the fourth. I would normally put her in at number 4. I'm not going to have room to do that because we've got complications. She's got a child from a previous marriage I'm going to have to show. And actually, I probably need to sort of expand this a little bit so that I can fit her ex-husband in there. Let's see. Oh, is she a twin? Oh, she's a twin. That's terrible. What a pain. Twins are hard when they're the client. Well, you may not have this case. This is the PKU case. Yeah, it's good practice. Okay, so she is actually a twin, which is a pain. There's her twin brother. Obviously, they're not identical because it's male-female twins. And there are, 4 other kids. 1, 2, 3, 4. And it says she has 3 sisters who are not affected. 1, 2, 3. And then one brother who died young. So remember, especially if we think that the death may be related to the condition we're interested in, we mark it on there, so we would mark him as deceased. We don't know that any of them were affected, and this is not perfect and beautiful. This is my rough draft, but I am going to try to line them up a little bit better. There. Okay, and there's my client. So she had a previous marriage, and she had a child in that previous marriage. So I'm going to give her her ex-husband here, and we kind of dash that line, and he's not quite to scale. Again, it's okay because this is a rough draft. So the rough draft kind of gives you a chance to figure out where everything goes, and then you can make it really beautifully and perfectly spaced. She has a daughter who it turns out is affected, which is probably why she's talking to a genetic counselor. Okay, so that would complete her side of the family. Oh wait, we have to, well, we don't know anything about her parents, but we know that she had them, right? I mean, biologically, whether you know them or not, everybody has parents. And there's no family history. It doesn't mention that she has any maternal or paternal aunts and uncles, but we can at least do that. So we show her parents, we show all her siblings, we show her grandparents, and it says that there is no genetic history. So that's one side of it. That's her. And because I'm working on Doceri, it's nice because I can do that. So now I got to look at her husband's family history. And this says that there he is. I'll put a star on him. He has 2 sisters. One sister is affected.
Are they sisters or brothers?
Oh gosh, they're sisters. Hey, good, I'm keeping you on your toes. Awesome. Yeah, they're sisters. So one sister is affected. And look at how automatic that was. You were like, those aren't sisters. Good. Good, good, good. And his one sister has a son. We don't know anything about her husband. We don't really care. And the son is affected. Whoops, and I just about made him a daughter. Okay. So, what else do we know about his family? He had a father and a mother. Neither of them were affected. It doesn't list any information about maternal aunts or uncles. There's her parents, and the paternal grandparents are unknown. It says they died young. We don't know what they died of. If you know a little bit about PKU, they probably didn't die of PKU. There are cases, especially as you go back a few generations, where people kind of do disappear from genetic record. So that would be your final pedigree. Now, this is, like I said, it's a rough draft, so my generation lines aren't quite perfect. They're not bad. But when I did this for real, I would have them neatly lined up. I would have, I would know what kind of space I needed for everything. What you're going to do for tomorrow is have rough drafts done for both of your clients. So if you have PKU, you just got lucky, and I just did most of your rough draft for you for one of them. If you have some other condition, you got a little bit of work to do. So tomorrow when you walk in, we're going to look at your rough drafts, and then we're going to start figuring out genotypes on these rough drafts. Okay? So homework for tomorrow is getting the rough drafts done for both of your clients. Does ethnicity matter? Because they notice that ethnicity is listed on all the clients where it's known. It doesn't matter for all conditions. But there are some conditions that have a strong ethnic trend. Tay-Sachs is a disease, and I did not do a Tay-Sachs case. It's too horrible to even think about. Tay-Sachs it's a recessive autosomal condition, and baby is born normal and healthy seeming, and hits all the developmental milestones, and then at 6 or 9 months starts to regress and go backwards. And it's because the brain is basically converted to fatty tissue, and the child lives to be 3 or 4 basically as a newborn, and they die because they lose motor function. They lose diaphragm control, and the heart stops beating. And so parents watch their beautiful baby who was making progress go backwards and regress and then die. Tay-Sachs is a gene that is predominantly found in Ashkenazi Jewish populations. That's Eastern European Jews. So if you are of Eastern European Jewish descent and you are married to somebody else who is an Ashkenazi Jew or who has Ashkenazi Jewish background, you're probably going to do a pretty good intake. When I was pregnant with my daughter, on your first visit at like 8 weeks, there's a whole sheet that, do you have any known genetic conditions in your family? Are you of any of the following ethnicities? And Ashkenazi Jew is on there. And if you check that box, somebody's going to check in with you and say, do you know if there's a family history of Tay-Sachs? Have either of you been tested as a carrier? There is a test now. It's a pretty simple one. And if you are both carriers, at that point you're looking at chromosome testing on the baby to see if you're bringing somebody into the world who's got Tay-Sachs. So, questions, comments. So that's why the ethnicity is listed on these. For a lot of them, it doesn't matter. But for sickle cell and Tay-Sachs, it does. For cystic fibrosis, it matters. European ancestry is a marker for CF. That's it.